Okay, so since directed line segments usually are pretty difficult, at least to begin with, I do want to go over another example. And I didn't graph this yet because this would basically be what you would be given or the problem that you would see. I want to find the coordinates of, in this case, point F along the directed line segment CD. So if it's along the directed line segment CD, that really means we're moving from point C to point D. It's important that you know the direction that you're moving or from what point to what other point you're moving. And then the ratio of CF to FD is 3 to 5. So the coordinates of C are given, -4, 5. The coordinates of D are given, and I'm going to graph those points in my coordinate plane. So if you have your own graph paper, it would be extremely helpful if you used that. But C has the coordinates -4, 5. That's in quadrant 2. I'm going to label it. D has the coordinates 8, 3. 8, -3. Sorry, I'm going to label that as well. And then I want to find the coordinates of point F. But the first thing I need to do is break up the segment, CD. And then I'm going to break it up into 8 somewhat congruent parts. The reason why it's 8, the ratio has to be 3 to 5. So you can always break it up into, if the ratio is like A to B, A plus B parts. So in this case, 3 plus 5, 8 parts. That should be a lot easier. So this is about the midpoint. Maybe it's even the exact midpoint. That's 2 parts. Take the midpoint again. That's 4 parts. Take the midpoints of each of those segments. 1, 2, 3, 4, 5, 6, 7, 8 parts. So it should be kind of a lot easier if the number of parts that you need to break it up into is even, like I did there. That's pretty darn accurate. But I want the ratio of CF to FD to be 3 to 5. So point F should be right here. CF, that's 1, 2, 3 parts, to FD, here's F and then here's D, is 1, 2, 3, 4, 5 parts. Okay. And so then we'll do something similar, just to kind of estimate, maybe it's about half to something around there. So once we actually come up with the coordinates of F, it should be about half to, since this is pretty darn accurate. Okay, but the rise from C to D, kind of like on the last example, should be negative. And then if you just count the number of squares, or you can use the formula for slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1 in order to calculate the slope or the rise over run. But the rise should be negative, first of all. You're going down from left to right. And in this case, the rise is -8. Again, it should be helpful if you're labeling things kind of like I am here. And then here's the run. Run should be positive. If you're counting up the number of squares, or you're using the formula for slope, run should be 12. And normally, if I'm writing what the slope is, 12 over -8, kind of like what you learned last year, you would want to simplify that by dividing both the numerator and denominator by 4. So it'd be 3 over -2 or -3 halves for the slope. I actually don't want to do that here. So I want to leave the slope unsimplified, because to find the exact coordinates of point F, I'm going to take, so F is 3/8 of the entire segment. So now instead of 3 to 5, it's 3/8, because we're going to take 3/8 of the rise and then 3/8 of the run to help us calculate the exact coordinates of point F. So rise, don't forget, that's the y direction. I'm labeling that because that should help me figure out exactly what I'm going to do with the numbers to figure out the coordinates of F. But again, we're taking 3/8 because F is, this is 3, and this part's 8 all the way to D. That should go all the way to D. But it should be 3/8 of -8 or -8 over 1. Okay, the math here is a little bit easier. You can cross count the 8s, -3. So really from C to F, you just go down 3. And then the run, that's the X. Okay, still 3/8, but now 3/8 of 12, or 12 over 1. Okay, I can multiply 3 by 12 and then 8 by 1. I'm going to do some cross canceling. 4 goes into 8, twice. 4 goes into 12 3 times. And then I can multiply. 3 times 3, 9 over 2. So 4.5. So go down 3 and then right 4.5 from C to get to point F. So we're going to start with the coordinates of C to get the coordinates of F. So negative 4, 5. I have everything labeled here. And negative 3. Even though I found that first, we're actually adding that, or in this case, subtracting because it's negative from Y. And so be careful. That's why I label everything, so I can keep track of things. So 5 plus negative 3, or 5 minus 3, and then 4.5, that was the run or X. We're adding that to the X coordinate of C. So doing the math from here, negative 4 plus 4.5, half or 0.5, and then 5 minus 3, 2. Half, 2. Estimate was pretty good. Those are the exact coordinates of point F.